Welcome back, everybody, to Slice. We've talked about what computer science is before, so let's have a little bit of a closer look, in particular with respect to the five Wyoming computer science domains. What are those? Well, we have computing systems, we have networks and the internet, data analysis, algorithms and programming, and finally, impacts of computing. All of these are linked, but let's talk about each one in turn and see how we can connect those. So the first one is computing systems, and that is really a very general term for pretty much anything that might involve computing. The laptop you might be viewing this on now or your phone is a computing system. It is a system that has many different components that all work together in some way to allow you to watch this video, for example. That's not the only thing you can do with it. You can do all kinds of other things. In particular, we are going to have a look at some programming, and you can use the same device to do this as well. More generally, computing systems can be very, very large. I have previously mentioned the research computing that we have here on campus at the University of Wyoming. That is also a computing system in the same way that a single machine, such as your laptop, is. Except that it can be much, much larger. We're talking in some cases about thousands or even tens of thousands of actual machines that might be much, much more powerful, even individually, than the laptop you have now. All of these are computing systems. What other computing systems do we have? Well, networks and the internet. These are other great examples of computing systems, different components, different nodes in a network that are connected through optical fiber, for example, or through a Wi Fi link. And each node individually has some computing power and performs some tasks that may be related to computing. In some cases, and especially in the internet, the purpose of the components might be just to enable the actual network and the internet, as in the computing that it provides is specific to the task in the network. When we're talking about the internet, for example, every time you go, for example, to a website to request some information, what needs to happen is that your machine generates a request, which is then encoded in some form that it can be sent over a network where a server, the machine that you're talking to on the other end, receives it, processes it, decodes it, and finds out, okay, you have requested this site. Okay, let me go and find this site. Here it is. This is then encoded in a similar fashion as your original request, sent back to you over the network again, and then displayed at your device in a way that you can view this. All of this requires a lot going on behind the scenes, and all of this is done in a way that it doesn't even really matter what kind of network you're using. For example, if you're talking to somebody on Zoom using video chat, it doesn't really matter whether you're connecting using a Wi Fi network, whether you're at home, whether you're at work, whether you're at a coffee shop, what kind of internet connectivity you have. All of it works exactly the same way. Of course, in some cases, it might work better than in others. In particular, it's usually a good idea to have a lot of bandwidth available. And if you don't have that, you might see video very stuttering and audio skipping and problems going back and forth. Uh, but that's really just an artifact of the capacity of the network and not really of the network itself. We can use different types of networks in the same way, and this is what makes them so powerful. Of course, the internet is probably the biggest network that exists right now, but networks go back way, way longer than that. Before we had the internet, we had the phone network. And that allowed us to communicate in not too dissimilar a fashion. Of course, video calling wasn't really a thing because of technical limitations. The devices didn't support it, and there wasn't enough bandwidth. But in principle, it worked in exactly the same way as the internet works today, except that it's much, much more powerful. The next Wyoming computer science domain is data analysis. And this is kind of a central part, especially in today's world because we're producing a lot of data and we want to somehow make sense of everything that's happening. For example, we currently have a coronavirus pandemic going on. Very important to make sense of this in practice because we want to know what should we do, what do we need to do, how do we work with this, how do we mitigate the impacts, what is going to happen going forth. Is this going to get better, is it going to get worse, what can we do to make it go away eventually, develop a vaccine. All these kinds of things at their heart rely on some kind of data analysis. We look at what's happening at the moment, for example, with existing COVID patients, with people that become infected and then recover, or in some cases, unfortunately, they don't. What can we derive from that? What can we get from this information? How can we acquire knowledge which then ultimately will help us to, for example, develop a vaccine? Data analysis is really at the core of science in general, not just computer science, but as I've talked about in the previous video, computer science is really something inherently multidisciplinary for me. It involves lots of different disciplines. Data analysis, in particular, is a great example of that because that is useful pretty much regardless of what you're doing. Even if you have nothing to do with computer science, you might have to do some kind of data analysis, and computer science provides the tools that you might need for the analysis that you want to do. And that starts with getting the data in the first place. This might involve communicating over a network like the internet. Computer science allows us to do this. Then you need to store this somehow. We might be talking about large amounts of data, for example, videos or lots of images or sound. Think about podcasts that maybe you want to analyze. We need to store all of this somewhere, and then we need to be able to process that information as well. That gets us to the next bit, the actual data analysis. What kind of tools do we have available for this? You're probably familiar with Microsoft Excel. That's just one example of a tool that you can use for data analysis. Also, again, enabled by computer science. And then finally, the results of this analysis we might want to communicate. Again, communication networks such as the internet come into play, but also document preparation systems like Microsoft Word that you're probably familiar with allow us to then communicate this information in a way that other people can hopefully understand it and that they can reproduce the analysis that we have done and hopefully come to the same results. So that brings us to the next domain, algorithms and programming, because everything that we have talked about so far is really underpinned by algorithms and by programming. Let's talk first very briefly about the distinction between those. An algorithm is an abstract way of expressing what a computer should do, very roughly. Then we have programming, which allows us to specify this abstract algorithm in a way that a computer can actually understand it. So you can kind of think of an algorithm as the design part and programming as the actual implementation part. Of course, the two are connected, but they are separate and they are independent. I can develop an algorithm and I have different ways of implementing this, different programming languages that I could use, for example, different ways of programming the same thing, even if I'm using the same programming language. Similarly, I can develop different algorithms for the same problem. So, really complementary concepts, but they underlie everything that we have talked about here. There's programming behind networks such as the internet, and obviously behind computing systems because we're currently using software. I'm using software to record this, you're using software to watch this. This relies on algorithms and their implementation, in particular programming languages. And that really brings us to the last Wyoming computer science domain, impact of computing. Obviously, computing and computer science has had a large impact on our daily lives. We can now do things because of computer science that we were not able to do even just a couple of years before. In particular, this is becoming clear now during the pandemic when we increasingly have to rely on remote communication on networks like the internet to talk to people that usually we might be able to talk to face, But now that doesn't necessarily seem like a good idea. So instead, we're leveraging things like Zoom, Skype, your video conferencing platform of choice. All of this enabled by computer science, all of this relying on algorithms and their implementation in programming languages to make all of this happen. So, computer science has a large impact on our everyday life, and this impact is only becoming larger and larger as we increasingly rely on more and more devices. You might have a laptop, but then you also have a phone, and you might have various other gadgets. I have this fitness tracker here, which also relies on some kind of computing, on algorithms, on programming, and networks like the internet to communicate the information in a way that I can then analyze it and draw some conclusions from it.